Well, look who decided to go live at 1 a.m. nonetheless. So, I figured now is as good a time as any to do an update on the trading platform project that I've been working on. Um, so, I'm trying to figure out the sort of phases, of my approach, phases of the application from beginning to end. Um, a lot of stuff I need to figure out. Python for finance. Um, so the the end goal is I've set a goal for myself in terms of performance. I want to start with something very crude, very simple, and in the end, um, I want it to be some form of high frequency trading. This is purely experimental. This is a prototype. This is not intended to actually be used for trading or an actual commercial product. I'm definitely going to be using it for you guys in terms of content, in terms of teaching opportunities. I'm definitely going to be sharing this journey that I'm going through, and hopefully that'll be helpful for you guys. It definitely is going to be helpful for me. I'll tell you that. I'm learning so much from this. Um, so high frequency trading, cloud hybrid. So some components are going to be in the cloud. So far, it looks like I'm going with AWS, setting up EC2 instances. Um, so that's the long-term goal. 1,000 transactions per second is the metric I want to hit. I want to see if I can hit 1,000 transactions per second. I believe, don't quote me on this, but I still have a lot of research to do. Some of these firms are doing crazy numbers, man. I think 5,000, 10,000 transactions a second. I'm hesitant to say 100,000 per second. I don't know if that number is legit, man. That sounds kind of crazy. 100,000 messages per second, 100,000 transactions per second, TPS, transactions per second. That sounds crazy. So anyway, the first instance is going to be what I call a stick figure version, which I already built. So the stick figure trading platform is super, super simplistic. It's exactly what it sounds like. Um, I'm not an artist. So if you wanted me to draw a picture of a house or a person, it would not look very well. It would not be very detailed. But I could do a pretty mean stick figure. That's pretty basic, just lines and circles. So it's something that I could do a representation of an image pretty quickly without a lot of skill, right? So think about doing that for an application. I don't have the capacity to build a high-end trading application, especially on my own. But I could spin up, which I did do, a stick figure version of it, meaning it is the most simplest interpretation that I could come up with of a trading platform. I even merged sides with instruments. So instead of having different products like you're trying to buy Apple, buy IBM, the only product is basically a color. There's red is sell, I think green is buy. um, so I oversimplified the very process of buying and selling. The market data is fake. It's just a random module from Python. So I'm just randomizing numbers. I'm connecting just via TCP/IP. Market data is UDP, so it's trying to get it fast. And I'm trying to build as many components. I'm trying to mimic an actual. What's up, Victor? I'm trying to mimic. Oh, oh man. I'm trying to. I'm trying to mimic as much as I can a real trading platform, but starting again with the stick figure idea. So there's a monitor to monitor all the applications, TCP connections, UDP for market data. There's a front end with what tkinter for the GUI, and then then you have the OMS server. you have the smart order router, you have the fix engine, and that's the beginning. So once I have that working, which I do, the first thing is the first performance metric is going to be, um, remember the long-term goal is 1,000 transactions per second. Long ways away from that. Just to get the whole cloud thing going. I'm not worried about performance right now. I already set up a AWS free tier account, and I might host the database there, um, or I might build a what's it called, Grafana. I might use Grafana for Python to do some kind of monitoring GUI. Who knows? But the first phase is max out performance locally. So I still have that machine. If you guys remember, I built that server back in the day. It's just an i7 3770K processor, 32 gigs of RAM. It's got a NVIDIA 680 graphics card. So it's 4 cores at 4 gigahertz. So I want to max that out as much as I can in Python. Now, obviously, Python is not what you want to be using for a high performance application, high frequency trading. That's understood, but we're doing this in phases. I want to work with what I have and max out what I have, and then get to the point where I can't go anymore, and then I will graduate. So the first phase is, what is the maximum throughput that I can get with Python being an interpreted language, being very, very slow, limited to, I believe, a single thread per instance. So I'm going to be very limited. I can't, even though you can do multi-threaded applications in Python. I think, what is it, global interpreter lock limits access to the CPU. So I can't have, these things running concurrently. So if I'm trying to do 1,000, I know I'm not gonna get anywhere near that in Python, but if I'm trying to get the maximum amount of orders per second, I'm gonna need to use multi-threaded. I don't know how many. I haven't gotten this far. How many threads per core? I have 4 cores. I'm gonna see how much I can do in each core. But the basic idea is I would have one Python program that's gonna spawn at least 4 other instances of itself, because each one of those Python instances should have access to the core and can run concurrently. So I could have 4 operations happening at the same time. Um, Again, I don't know if it's going to be one per core. In terms of threads, is it just single thread per core? I don't know. I'm not that far along with things yet, but that's the basic idea. So a multi-threaded Python application trying to, and first of all, let's understand what the problem is. Why is this difficult? Um, when we say generating orders, what we're talking about is, I would be generating a parent order. So in the front end GUI, you're gonna select a symbol. Obviously, before we get to this stuff, we're gonna actually start introducing actual instruments and not just my fake red green thing. So when we get to that point, what you would do is in the GUI, you're gonna enter your order. So I want to buy 1,000,000 shares of IBM. Right? That's my parent order. And I don't want to jump the gun here, but so there's my parent order, right? The thing is, I need to take that parent order of 1,000,000 shares of IBM and break it up into a bunch of child orders. So imagine 1,000, break it up into 1,000 pieces. So 1,000, so divide 1,000,000 into 1,000, and how many ever orders that is, that's how many orders you have to generate. The problem is, every order you have to do pre-checks, because again, I'm trying to be as realistic as possible. So in a real trading platform, we're not just going to spit out a bunch of orders and send them out. We need to validate the symbol that we're sending out. We need to validate there's calculations in terms of the prices that we're going to use, because like you're using an algorithm, it's going to be picking prices for you based on what strategy you're using. So there's calculations that have to occur. There's risk checks that have to occur on all these orders. So that's the problem. Every single order that we are generating um, has a has a there's a list of things that need to be processed. So that's CPU time, and that is what the problem is. To do the processing on thousands of orders in less than a second. That's the end goal, but that's the kind of overhead we're dealing with. So again, first I would max out my CPU using this multi-threaded approach, um, and then I'm this is just a rudimentary idea right now, but I was thinking I could expand to using the GPU because that's something that they would use in high frequency trading. And it's really interesting what these guys are doing. Who else is in here? Freestyle. Time to run this on I don't know what that is. Anyway, so in high frequency trading systems, they are just exploiting every single thing they can. They're using concepts like NUMA, non-uniform memory access, where they are. It's so extreme that they are considering the distance. I believe it's the distance of the memory from the physical CPU. So with Numa, you would want to set up these, I forgot the name of it, but basically you group the memory, parts of the memory with a particular core, I believe. I might be mixing some of the terminology, but basically for for a core that is doing some kind of processing, the data that it's accessing, right? So it's doing math on a number or something, right? Where's that thing stored? It's stored in the memory that is physically closest to that processor, because obviously you're going to get the maximum performance doing it that way. So you would want a system that supports non-uniform memory access, and then you'd want to design your application to support that. Now, I'm not going to be able to get anywhere near that. That is an example of what's happening in the real world in terms of, the real pros who build these things and develop these things, these hedge funds or whatever. They're doing craziness like that. They're doing kernel bypass where they are, so you have data packets coming into the server and you're bypassing the OS kernel and going, I believe, straight to RAM, I think. The data comes into the NIC, and instead of going to normally it would go to the OS kernel, but it goes straight to the RAMs, so part of memory that the application is using. So all kinds of tricks, man. Um, but I'm getting ahead of myself. So anyway, one of the things that they would be doing is using GPU cores to accelerate performance. So you're using you obviously they would using a lot more cores than I would. I mean, it could be, I don't know, 60, 128, whatever cores. That's how they can process all these orders. They're also tapping into GPU, and it's just like when I first read about that, I was just like, wow, that makes total sense. I mean, you have these, they're essentially a type of processor. I mean, it's normally used for graphics, right? But it's a processor, right? So basically, in high frequency trading, they will repurpose the GPU cores and use it to do some of the math. And I think that's what they're tapping into, because a lot of the graphics is mathematical. So they probably have figured ways to exploit some of the calculations that are similar. Like maybe you need to do certain types of I don't know, math that is similar to graphical calculations. I don't know. I'm not a programmer. Um, but that is what they're doing. So I want to see if I can do that. I don't know if that might be. First of all, probably can't do that in Python. I'm just thinking that might have to wait until the next phase. But if it can be done, I will find out and I'll try to do that. So maximize the CPU cores, tap into the GPU cores, and then hit that bottleneck of I can't get in any better than that. Then the next phase is I probably have to go to a interpreted language. Right now I'm leaning to C++. plus plus. Um, you're essentially trying to exploit temporal locality. Essentially, you wouldn't want it to go to RAM. You want it to SRAM. Once you go to the main memory, you're talking massive amount of cycles. Yeah, I obviously have a lot to learn. This is a lot of this stuff is new for me. Um, but it is exciting. I'm enjoying the process, and I'm definitely going to benefit from all this knowledge, building this, and that's the whole point, man. It's an educational exercise. I'm learning as much as, I'm hoping that you guys will as well when I build this and share it with you guys. But anyway, the next phase would be going to a compiled language. So I'm thinking about C++ right now. If you guys have any suggestions, any ideas, I do not have any C++ experience. I'm a little bit nervous about that. I don't know because this is a lot. This project is a lot, and getting into a compiled language that's totally new. I don't have any experience with it. Like, how long is it going to take? Is it going to be difficult? And blah, blah, blah. So we'll see. I'm excited, but I'm also nervous a little bit about what am I getting myself into. But if I really want to get the performance gains, I'm gonna have to leave Python behind. But I'm thinking what I might want to do is have my cake and eat it too. So hybrid model. So Python front end. So I can stick with tkinter, you know, having that already built and functional. I don't need to build every single thing in C++. The point of C++ is the high performance that I need. And what do I need that for? I need it for the calculation, the pre-trade risk checks, and all that stuff, generating those child orders. That's what I need it for. So the front end could stay in tkinter. So you do your order entry, you send your parent order, you send it to the OMS server. The OMS server gets rebuilt into C++ instead of Python, so it can be able to receive that order of 1 million shares of IBM, and it can dice that up in a fraction of a second. Boom! Thousands of child orders, everything, all the pre-trade checks are done, and spit it out, send it out to the smart order router, send it out to the fix engine. And then coming back should be easier because you don't have to do the pre-trade checks. So the fills coming in, that's going to be bulk inserts into the database. And then you somehow stream that to the front end GUI. Fortunately, you don't need to see every single order coming in. What the trader is interested in is what his P&L is. So total executed, what's my average price? So those numbers can be quickly received even by, I mean, that's nothing. So the Python was no problem there. It's still gonna be, there's still gonna be some issues in terms of a lot of transactions coming back in, but it should be easier coming back in than going out. So at that phase, we will start to step up the cloud. So I'm looking at the high performance instances in AWS. I think I wanted to start with the M5. Was it M5, M5.8 something X large, EC2, which I think is 32 virtual CPUs. I don't remember how much RAM. I think 128 gigs of RAM or something like that, which is it's decent. Um, and we'll see what we get done with that. So do some performance testing. What kind of numbers can I hit with that? And then if I need to, I can upgrade to one of their. They have some high performance instances. I forgot what it's called, um, but whatever. I mean, that's where I'm at. That's where I'm at. Obviously, there's a lot between now and getting to the end of this. Um, so right now, what I want to do is finalize my plans in terms of all the phases, and then I want to start converting the stick figure that I have right now, which is super simple, and at least get it to the point of order types. I don't have any order types right now. So market order, limit order, just for now. Introduce a security master. So security master would be a list of all the securities that are tradable. So, whatever stocks that you can trade or options, whatever it is, right? Everything that's tradable is going to be in that file, be a flat file. that has the details about the every instrument. So my system at that point would load this file up, so it is aware of what is tradable. So when you type in a symbol, it knows what you're typing in, whether it's valid or it's not, it's tradable or it's not tradable. It knows tick size and whatever. And then I don't know about market data. I gotta figure that out. Obviously, I probably want to graduate from doing a randomizer thing that I'm doing with the Python. I used to pull data from Yahoo Finance, but I think they shut down the API or something. I don't know, but that's something I got to figure out. But right now, I want to get a step up on the front end that it can do a little more than it does right now. And I think I would like to start focusing on the parsing of the fix log. So basically, get into constructing my own fix engine. So being able to the front end generates an order in the database. So you have an order in the database. The fields are proprietary to the trading platform, and you need some kind of I forgot what the term is, a converter, translator, basically something that is going to recognize. So for example, in my trading platform in the database, I may call the symbol, I may call it SYM. I may call it instrument. I could call it whatever the hell I want to. Problem is, in the fix world, we need to convert it to something that fix understands. So obviously, symbol is tag 55, blah blah blah. So I want to work on a Python script that can, I guess, convert. I gotta look into how the what how the fix engines work behind the scenes, but basically be able to take the the proprietary message coming from the front end and convert it into a valid fix message and all that good stuff. So that's where I'm at. Anyway, I'm gonna go to bed. It's way past my bedtime. It's been a busy day, a long day. It's a big project, so props to you if you get it to run Python even. I appreciate it, man. And until next time, this is a computer programming university signing off. This is what it takes. That's part of why I wanted to do this, because people always see the final result. They don't see the behind the scenes. It's literally what time is it right now? It is 1:22 a.m. in the morning, and I've been working on this for hours. I was about to go to bed, and then I said, you know what? Let me do some more notes on this on the design. Um, and I was gonna read some of this Python for finance that I have here, but because I spent the time talking to you guys and working on the action plan, I think I'm gonna, you know, call it quits. And then first thing tomorrow, I will pick things up and move on from there, and I'll keep you guys updated. So until next time, remember the first step in learning is to smile. All right, guys, I'm out. Ciao. Do, 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 do.